I put the unit circle song on Canvas along with a key, along with blank ones and stuff. You can print if you want to, but remember I have extra white ones over here to copy or to take. Don't take another pink one. Shh. Please only take the one pink one that I gave you because I just have a certain amount of pink ones. I printed a whole bunch of the 2-to-a-page white ones, okay? And so I put that song on there because it's kind of cutesy and annoying, and some people, it drives them crazy, and I think it's kind of funny. It will get stuck in your head. But some people do learn by music. Like, think about how a 3-year-old learns the alphabet, 26 letters in a row. Like a 2-3-year-old can say the whole alphabet. Music does that for us, okay? It is not the best way to learn or memorize the unit circle. It only talks about degrees. It only talks about radians. It doesn't talk about the ordered pairs. And it's really only good for this one quiz we're going to have, which is timed filling out the whole unit circle. That's not the most important quiz we're going to have, and I'll talk about that more at the end. But getting ready for Friday is being able to correctly put all of this onto a blank one of these. It'll look just like this in 5 minutes or less, which is 100% attainable. Even if you're feeling a little intimidated after yesterday, you won't by the end of today. The feedback I've gotten from the other classes is like, oh, I get it now, okay? It is your job, though, to really pay attention and ask questions. You need to notice all of the little ins and outs, okay, all the little tricks I'm going to be showing you. So let's go ahead and start with degrees, okay? And remember, this is just the X and Y axis of the regular old coordinate plane, right? This is the origin, and we always start, our initial side is always the positive x-axis at 0 degrees. So you see the lines that have a degree symbol, you don't even have to draw a degree symbol, it's already there for you. And then we have 30, 45, 60, 90. That is quadrant 1, okay? And remember I told you, even though I'm an expert at the unit circle, I don't mind bragging about it. I know it really well, as I should, because I'm your teacher. The part that gets me sometimes is the degrees. That's what slows me down if I'm trying to do this fast. But remember, our fallback is the math of the degrees. You can easily, as long as you can get pretty much quadrant 1, or even from here to here, because it's just 30, 15, 15, 30. So at each of the axes, you're adding 30, and in between, you're adding 15. So even if I got stuck here and my memory wasn't working, I know how to add 30 to 90 without even having to write it down, right? And then you would add 15, add 15, add 30, which gets us to the line to 180 degrees at this quadrangle. Okay, and then we're 30, 15, 15, 30, the whole way around. So adding 30 to that, adding 15, adding 15, adding 30. The reason degrees are not known as well as radians is, I think I mentioned to you, we don't use degrees as often as we use radians. We need to be familiar with them and know how to find them, pretty much with the way I'm just telling you. But radians are much more commonly used, okay? Okay, so just let's finish this up. Adding 30, adding 15, adding 15, adding 30 gets us one full revolution, which is 360. Let's identify a few patterns we might see. Quadrant 1, all of your angles are less than 100. Quadrant 2, all of them are in the hundreds. In quadrant 3, they're all in the 200s. And in quadrant 4, they're all in the 300s. Also, all of your middle angles have in the ones digit is a 5, because all the rest of them are zeros at the end. But the ones in the middle are the only ones that end with a 5. Okay, so there's degrees. Let's go on to radians. Now, we talked about the denominator of the radians yesterday. We'll review that. We didn't talk about the numerators. So today I'm going to teach you all about the numerators, which are super, super easy, I promise. All right, so at 0 degrees, we're also 0 pi. And you can put the pi symbol next to it. It's not wrong, but a lot of times you won't see the pi symbol written, so I kind of leave it off. All right, so if it's got a degree symbol, you know it's degrees. If it doesn't have a degree symbol, that means it's radians. But again, it's not wrong, and you will still see a pi symbol right next to it. So 0 or 0 pi, okay? And these are like fraction bars, guys, so use them. So it just saves you time when you're filling it in. what is the first denominator we come to? Pizza, 6. Then, and then 3. We've got to know that. And the numerators are all just pi. And then we get to our first quadrantal, which is pi over 2, which we learned about last Friday, but there it is. So you have to remember that the first angle you come to's denominator is a 6. And I told you guys yesterday that a lot of students confuse the 6 and the 3 because we know that we're starting here and we're getting bigger as we go. And a lot of people just think 6 is bigger than 3, which it is, but not in fractionally, right? 1/6 is smaller than 1/3, okay? So remember that. Think pizza here that we went over yesterday, 6, 3, all right? Now, when we get into quadrant 2, these denominators just repeat themselves, okay? The two angles that are next to, remember, this is the y-axis where pi over 2 is. These are going to have the same denominator. This is going to be a 3. They are the same. Then a 4 in the middle are always your 4s. The one in the middle is always 4. And then 6. The 6s are the ones that are next to the x-axis. Now the numerators. Numerators, really, really simple. I think we talked about this yesterday, that the top half of the unit circle, all of your radians are proper fractions, meaning the top number is smaller than the bottom number. Like this is 1/6, 1/4, 1/3, 1/2. Here, they're still going to be proper fractions because they're going to be less than 1 pi, right? We don't even get to 1 whole pi till we get here. So these are still less than 1. The way we find those numbers is you subtract 1 digit from the denominator. So if you subtract 1 from 3, we get 2. Subtract 1 from 4, you get 3. Subtract 1 from 6, you get 5. Okay? So subtract 1 from your denominator. Sorry, go ahead. You have to have the pi there. Very important to have the pi there. Yep, exactly how I'm modeling this for you is what you're going to do, okay? So notice, those are all proper fractions, meaning the top is less than the bottom. Now we're crossing past 1, so these numbers are going to be improper, okay? So let's get the denominators first. What's the denominator of this guy? 6, 4, 3. Very good. And here's the thing. All you have to do in this quadrant is add 1 to your denominator. 7 pi over 6. 5 pi over 4. 4 pi over 3. Make it make sense in your brain. 7, 6 is 1 and 1/6. Okay? So it's 1 and a 6. Okay? 1 and a 4, and so on. And then we get 3 pi over 2. Our top quadrantal and our bottom quadrantal are the only two radians that have a denominator of 2. Look at it. The minute you see a denominator of 2, you know it's either the top or the bottom. Okay? They're the only radians that have a denominator of 2. All right? Now, what would the denominator be for this one right here? 3. Remember, on either side of the x-axis, 4 and 6. Now this one, these are going to be improper as well. Oh, let's put 2 pi here. 1 full revolution is 2 pi. These are going to be improper as well. The top number is still going to be bigger than the bottom number. This is a little trick that somebody, not me, came up with to help us remember this quadrant, and that's at 5, we go to 7, 11. At 5, I go to 7, 11. 5, 7, 11. And there's your radians. Okay? Lastly are our ordered pairs. Now, when you take this quiz, you're going to have to do the degrees, the radians, and the ordered pairs. That's it. We're going to write some stuff in on this page because this is going to be our really awesome go-to one-stop shop for anything to do with unit circles. So let's just add some little notes on here. We talked yesterday about in algebra and in trig, points are called x's and y's in that order. In trig, cosine, sine, in that order, okay? So we are not going to get those confused. It's in alphabetical order. C comes before S in the alphabet, just like X comes before Y. So let's just keep that in mind. We still sometimes call it X and Y. That's not wrong, but cosine and sine are more common. And so let's do our quadrantals first. Now, I told you last Friday that the quadrantals are the number one mistakes I see when it comes to the ordered pairs. So you will see me oftentimes, and I'm going to be modeling for you today a lot of like what is going to be expected of you and how to get through it. And one of the things I recommend with the quadrantals, and this is just me, I like to throw lots of different things at you, and something will stick for some of you, and some people won't find it useful. But me personally, I draw in the air a lot. Like when I'm coming up with these points, because I know they are the 4 that a lot of people mess up on, I'm not messing around. Because I mess up on them too. 1s and 0s, that's what's repeating in those 4 corners, the quadrantals. So I might, you'll see me doing this all the time in the air when I'm coming around and helping and, checking something. I'm doing this in the air because I'm putting my finger on the origin. And if I'm going to the right, I can just see it. I can go, okay, that's right 1, up or down, nothing. So if I go to the left, that's -1, 0, right? And then going up, left or right, 0, up 1. Don't forget what you guys already know. And that's how to graph points on the coordinate plane. Okay? So let's make sure we know those quadrantals really well. Good. And then we can start filling in the 3 in the middle that just repeat themselves over and over again. So before I go on to that, I want to remind you of something. I'm going to keep reminding you of it, is that with your radians, all 4, look at my fingers, all 4 of your denominators of 6 are on either side of the x-axis. I call it hugging the x-axis, right? Those are my 4 denominators of 6. These are my 4 denominators of 3 on either side of the y-axis. All my denominators of 4 are in the middle, and then at the top and the bottom are my denominators of 2. If you have a denominator of 6, which there are 4 of them on here, you have the same ordered pair. If you're a denominator of 4, all of you have the same ordered pair. If you're a denominator of 3, all of you have the same ordered pair. What changes from quadrant to quadrant then? The what? The signs, okay? Anybody remember, without cheating and looking back, what was the first, what goes right here? Who starts the party? No. It's square root of 3. If you can remember this, put a star next to it on your paper or something, then the rest of it all falls in place. So I always remember, this is what I see. This is a memorization. I see this in my brain, because once I know that, I know all the patterns, I can fill the whole rest of the thing in. All the denominators are 2, so that's non-negotiable. And the only other fraction that ever goes with the square root of 3 is what Zach said, which is the 1/2. And so that means the denominators of 3 have the 1/2 first, and then the square root of 3. So square root of 3 starts the party. That's the first thing we see. And then the rest of it falls into place. In the middle is your square roots of 2 over 2, square root of 2 over 2. Okay? Now, this is just going to repeat itself all around the unit circle like you guys agreed, except for the signs. So here's your coordinate plane, right? Quadrant 1, 2, 3, and 4. We talked about this yesterday. All students take calculus. These are your positive trig functions. And we're talking about 3 of them, sine, cosine, and tangent, which I'll teach you in a minute. And this is just telling you who's positive. So if your letter isn't there, that means you're negative, okay? So we're in quadrant, we just finished quadrant 1. A means all are positive. Sine, cosine, tangent, when we learn it, everybody's positive in quadrant 1. Now we go to quadrant 2. And I'm going to look at my denominator of 3 here is going to match my denominator of 3 here. So what's going to go in my first spot? And I'm not even going to worry about signs yet, but you're right. 1/2, that means square root of 3 over 2 goes here. This is a middle. And then next to my x-axis, also known as my denominators of 6, is this ordered pair. And using our signs, whether you use this or you draw in the air, what this is saying is sine is positive. So that means by default, cosine and tangent are negative. But on the unit circle, it's almost easier not to use this. And just think in the air, left is negative, up is positive. So all of my cosines are negative. And guys, when you take the quiz, I need you to be obnoxious like this. I need to see that you 100% meant to put a negative there. I'm not going to guess if there's a negative or not. So make it nice and big, loud and proud, and so you get credit for knowing that that's negative. Okay? All right? Now let's go down into quadrant 3. My denominators of 6 start with what? Fast. Square root of 3. All of my middles are square root of 2 over 2, square root of 2 over 2, and then 1/2 square root of 3 over 2. In quadrant 3, only tan is positive. That means sine and cosine are negative. For left and down, the obnoxious, negative, 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 negative. Okay? Last quadrant, denominator of 3. What's it start with? Fast. 1, yes. The middles, and the denominators of 6. Quadrant 4, only cosine is positive, so that means sine and tangent are negative. And that makes sense because if I go to the right, I'm positive, down, I'm negative. So this guy's negative, this guy's negative, this guy's negative. And that is the unit circle. So again, all of my denominators of 6 have the same ordered pair. All of my denominators of 3 have the same ordered pair. Watch your signs, okay? Question before we move on to tan? Yes, yeah. All right, so let's talk about quadrant 1 tangent. Short for tangent is tan, so you can see or write that for me. So we're going to do quadrant 1 tan values and our quadrantal tan values. These are super, super easy once I teach you the trick, okay? But that's a U values, okay? And again, all this extra stuff I'm writing in the margins is not part of the quiz, okay? This is just for you to have all on this one paper. So quadrant 1, what are our choices? We have pi over 6, pi over 4, and pi over 3. Right? Now, I'm going to do some work to show you what these answers are that you don't have to do. In fact, it'll slow us down if you do it. If you want me to help you with it later, you can, but you never have to do this work, okay? I want to show you how I got the answers. It's going to help us with future work like tomorrow and stuff when we're not on the unit circle. But when it comes to the unit circle, we don't want to have to do any math. I don't want you to have to go off to the side and figure it out. I want you to know it here without having to show any work. Okay, that's the whole point of it. So let me show you what I mean. Okay, so you can just watch, guys. So if I asked you for tan of pi over 6, it all starts with your ordered pair. Okay, so, and we're going to practice that more in a minute, but this is the ordered pair. Okay, so that's the ordered pair for pi over 6. Guys, tan has a whole bunch of ways of defining it, and we'll be talking about them a lot. Sine over sine, sine over cosine, or y over x. These are just fractions that you can make to get tan. So if I look at this, if I'm doing sine over cosine or y over x, that's putting 1/2 over square root of 3 over 2. So just watch, guys. So it's 1/2 divided by square root of 3 over 2. This is a long little, it's an involved little problem, so just watch. Whenever you have to divide fractions, we do something called keep, change, flip. You keep the top fraction, change division to times, and flip the bottom fraction. Then I'll simplify it. Those 2's cancel. I'd have 1 over the square root of 3. We're not going to leave the radical in our denominator, so I would rationalize it. So I'd multiply the bottom and the top by the square root of 3, which would get me square root of 3 over 3. Okay, I went through it really fast because you don't have to do the work. So what I want you to write here is what the answer is, square root of 3 over 3. And I'm going to come back after I do the next two, which are a lot easier. I'll show you the next two, and then I'll come back here and show you the trick. Okay? We have a quiz on Friday. So what part is on the quiz, guys? Degrees, radians, ordered pairs. Okay? So it all starts with an ordered pair. And when I do y over x, that puts two identical twins in a fraction together, right? If you have the same number on top as bottom, they cancel and you get a 1, just like 4 over 4, 5 over 5, or x over x. If you have identical twins on the top and bottom, you just get 1. So that one's pretty easy. All of my denominators of 4 are going to have a tan value of 1. And the last one, pi over 3, again, aren't you glad you don't have to do all this work? There's the ordered pair for my denominators of 3. Y over x would be square root of 3 over 2 over 1/2. It's going to go fast. Keep, change, flip. Keep my top fraction, change division to times, flip the bottom fraction, choose cancel, simplifies to that. Okay? So, again, you don't have to do that work because now you know the answer to all of the tans. And here's how you easily memorize it. So all of the denominators of 4 are going to be 1 or negative 1. And we'll talk about signs more in a minute. But these are the two that are super similar, right? One is square root of 3 over 3, and one is just the square root of 3. And students get those confused all the time. But if you learn my trick, you shouldn't get it confused. So 3 plus 3, if you add those together, you get 6. If you're just a 3, you're just a 3. So it's that simple, okay? So if you have a 6 as your denominator, and there's 4 of them, this is your tan value. If you have a 4 in your denominator, this is your tan value. There's 4 of them. And there's 4 of these, 1 in each quadrant, and that would be the square root of 3. So look at your denominator. Denominators of 6 have the 2 numbers that add up to 6. The denominators of 3 are just the 3, okay? And then as you go around the unit circle, you can either use this trick or the drawing in the air trick. Like if I'm wanting to know tan of 5 pi over 4, I already know the answer is 1, but what's the sign? Oh, a negative divided by a negative is positive, okay? Tan would be negative in this quadrant because a positive divided by a negative is negative. So the moral of the story is you already know. If two signs are the same and you divide them, it's positive, right? A positive divided by a positive, positive. Negative divided by a negative, positive. If the signs are different, one's positive, one's negative, your tan value will be negative, okay? So you can use in the air to figure out signs, use this trick to figure out signs, right? Here's what this is all about, okay? So what I'm about to show you is what the next level of trig quizzes will be. As I told you at the beginning of class, we're going to do one of these 5 minutes, putting everything that's degrees, radians, or ordered pairs on the unit circle successfully. Later, next week, not too much later, we will have something called trig quizzes, where I give you a strip of paper with 10 trig questions on it, and you have to come up with the answers without a unit circle or a calculator. Let me show you what I mean. For example, if I said, what is sine of 7 pi over 4? This is the exact process to go through. Is that your phone? So guys, listen. First, so sine, cosine, and tangent all come from the ordered pair. So, and you know your ordered pairs by your denominator. So the minute I see a 4, whether I would write it or not, I can write it down if I want to. I can see it in my head if I want to. You'll decide what level you are on, what makes you comfortable. The denominator tells me my ordered pair. The numerator tells me what quadrant. Improper fraction, more than 1. This is quadrant what? 4. Yes. Remember, improper fractions are either quadrant 3 or quadrant 4. And in quadrant 3, the difference is only 1, right? Subtract 1, subtract 1, subtract 1. Okay? So then I go, okay, I want sine, that's this value. And then what about my SIGN to the right and down? That would be negative square root of 2 over 2. That's as fast as you have to do it. Let me show you another one. Tan of 5 pi over 6. I see a denominator of 6 in the word tan. I know it's the answer that adds up to 6. Just from that denominator, I know it's square root of 3 over 3. Just like this denominator, 4, was square root of 2 over 2, square root of 2 over 2. And then I think, okay, what quadrant am I in? The numerator tells you your quadrant. Quadrant what? What would this one be, guys? 2. It's a proper fraction, right? 5 over 6. Tan, that's positive, negative. That's a positive divided by a negative would be negative. See how fast I did that? Not super fast, okay? There is nobody, unless you have a photogenic memory, and maybe you do, nobody should be able to do these, like if I say because I can't, cosine of 4 pi over 3 is blah, blah, blah. I can't even do that. This is as fast as I do it. I'm sharing with you my exact process. I might not have to write it down, but that's okay. That's a little step stool until you get more comfortable with it. But I see a 3 in my head. I'm seeing this. I know that's my ordered pair for all my denominators of 3. My numerator is 1 more than the denominator. I know that's quadrant 3, and I wouldn't necessarily write either of these. I kind of come up with this in my brain. And then I think, okay, in quadrant 3, everybody's negative, and cosine is the x value. There it is. It takes me about 15 seconds to come up with an answer. Okay? That's what you guys need to be practicing. This is what the unit circle learning is for. This. There are going to be so many problems in our future together where you have to come up with these values as part of a bigger problem. Just like learning your multiplication facts, used to be just memorizing those, and then it was like one of the 15 steps in a problem. We had to do 5 times 7 and then do something else, okay? So this is everything. Being able to come up with, oh, I forgot to do the quadrantals, tan values, but being able to do this. Let's talk about those, because those, I don't have a great trick for you. Some of you might be able to memorize these. Let's do the quadrantals. 0 and 2 pi, they share the same spot on the unit circle. They're coterminal. Then we have pi over 2, pi, and 3 pi over 2. So there's my quadrantals, okay? So for me, I could memorize these maybe, but my brain's too busy, full, and not good at memorizing, especially at my age. So for quadrantals, the ordered pairs are so easy that I just do it real quick on the spot. Here's what I mean. If I was asking you to find tan of all the different quadrantals, like for example, 0 or 2 pi, I would think of what the ordered pair is. The ordered pair is 1, 0. And tan is your y over x. So tan of 0 or 2 pi is 0 over 1. When you simplify that, it's just a 0. 0 on top is 0, okay? But look at what happens at pi over 2. My ordered pair is that, and when I do y over x, I get a 0 in my denominator. Never allowed to have a 0 in your denominator. Numerator is fine. But anytime you have a 0 in your denominator, you actually get undefined. And you actually would write, and you can abbreviate on UND. Think about pi. Pi is negative 1, 0. Put the y on top, it's 0 on top, right? Negative 1, 0, y on top, 0 on top. We're good with that. Think about 3 pi over 2. 0, negative 1. Negative 1 is on top of 0. That's bad. So some of you might just memorize those, but for me, it's just as quick to see that ordered pair, put the y on top. It's either going to be 0 on top or 0 on bottom. 0 on top, good. 0 on bottom, bad. Okay? So, without saying things out loud, well, I have a little sticky note here. I'm almost done, actually. I just have 2 more things to go over with you, and I'll check homework and let you guys just practice this and whatever. Some of you might have noticed in the homework yesterday, there were symbols like that or that. That's an alpha, that's a beta. In the Greek alphabet, I've already taught you guys theta. It's just, I think it's an S actually. But it's a Greek letter. It's part of their alphabet. Just like we use X as our most common one when we have a variable. Well, there's alpha, there's beta, there's gamma, okay? And those are horribly drawn. I don't take off points because you can't draw nice Greek letters. It's no big deal. In fact, it's pretty acceptable to change them to letters in the English alphabet if it really makes you happy. But just understand, anytime you see those weird symbols, they're just letters of the Greek alphabet. That's your variable, your unknown that you're solving for, okay? Most commonly used is theta and x. We use x a lot, but they throw in any letter they want, okay? So just be comfortable seeing it. So having said that, I'm not going to write on this, I'm reusing it, and I don't want you to call out. So looking at number 23, just think about it for a second, and then I'll ask you guys what you think. Which one of these, A, B, C, or D, would be in quadrant 2? So think, just look at them, see if you can tell quickly. Quadrant 2. Which one is quadrant 2? Anybody say A? B? C? B? Okay, it's B, right? Quickly, knowing that quadrant 2 is a proper fraction, difference of 1, okay? How about quadrant 4 for 24? Which one of those is quadrant 4? C, right? C. It's got to be improper, right? So really that only eliminates B. But this is only a difference of 1. This one is quadrant 3. This one is also quadrant 3. Nope, sorry, quadrant 2, because it's one less on top, so that's quadrant 2. 3, 2. This is improper with a bigger difference than 1, right? There's a difference of 3 there. That's quadrant 4, and that's a quadrangle, okay? So being able to tell by looking at the relationship between the numerator and denominator is important to be able to tell what quadrant we're in. Last thing, negative angles. Negative angles give some of us a headache. I'm going to show you in 5 seconds how you can know every single negative angle as long as you know the positive ones, okay? Because we had a homework problem yesterday, which was negative pi over 2. And you had to find cosine and sine, okay? So as you have learned, cosine and sine come from the ordered pair. So some of you were like, well, I don't know the negatives, but you do. Here's how you find any negative theta. Find the positive version of that angle. So find where positive pi over 2 is. That is up at the top, right? And then you just cross the x-axis. So wherever your starting angle is, the positive version of it is, if it's in this hemisphere of the circle, you just drop down to the bottom. If it's on the bottom, you drop to the top. So positive pi over 2 is right here. Negative pi over 2 is in that same position across the x-axis. What that means is 3 pi over 2 and negative pi over 2 are coterminal. They share the same spot on the unit circle, which means they share the same cosine and sine. Okay? Let's try another one. If I asked you for negative 7 pi over 6. Okay? If I wanted you to tell me something about that angle, who is it coterminal with? Well, find positive 7 pi over 6. Here it is. Cross the x-axis. You always cross the x-axis, nothing else. And guess what? It has the same denominator. So you don't even have to be like, wait, do I go up 1? Is it here? It's this one that has the matching denominator across the x-axis. So that means negative 7 pi over 6 is coterminal with 5 pi over 6. They have the same ordered pair. Okay? If I asked you negative pi over 3, here's positive pi over 3. Where's negative pi over 3? Cross the x-axis, find the like denominator, just right below it or above it. Okay? So from now on, we shouldn't be afraid of negative angles because you just go to the positive one of that angle and cross the x-axis. Go directly up or directly down. Good? Does that make sense? Can't read your faces, so I'm not telling you. So here's my advice, guys. I'm going to check homework right now. You have the rest of the time to kind of play with this. If I were you, I would grab some of the white copies over there and start timing yourself. I would tonight at home, tomorrow night at home before your quiz on Friday, put a timer on your clock, 5 minutes, see if you can get it done. You now all have a key, right? Just do me a favor, don't take any more pink ones. Like I said, I don't have enough for everybody if they take more. But help yourself to several of the white ones if you want. There's 2 to a page, all right? And go ahead and get... There's the homework check. Start quizzing yourself.